All right, guys, we're going to do some questions involving quadratic modeling. All right, a lot of these questions involve a ball thrown in the air or a projectile shot up into the air or a rocket, like your toy rocket shot into the air. And there's a couple of assumptions that you got to make. Assumption 1, okay, time starts at 0. All right, you can't have time before 0. Another assumption is when you shoot this toy rocket into the air or you throw a ball up into the air, eventually the ball has to hit the ground. All right, when it hits the ground, all right, the height's 0. So we're going to begin at 0 for the time, which is the x-axis. And we're going to end at 0 for the height, which is the y-axis. All right? So it's real key that you have your calculator for this. All right? We're going to graph this function. All right? Negative 16, parentheses. You're going to put x's in places of t's. X minus 2 to the second plus 144. All right? We're going to try to graph it. But what you're going to find on the graph is it's going to get cut off, because it starts at a height of 144. Really what we care about is the table of values. That's going to tell us pretty much everything. So I'm going to go to my table. And again, you need to start at 0 because you can't go backwards in time. The only person that can go back in time is Doc Brown and Marty McFly. Hopefully you know that movie reference. All right, so we're going to start at 0. So what I would do is I'd write a little table. We're going to start at 0. And if you look at the table of values, when you get to 0 for the y, that's when you're going to stop. Because otherwise, if you get negative values, you're going below the ground. When it hits the ground, it hits the x-axis. So we're going to go from 0 to 5. At 0, it's 80. And then it goes up to 128 to 144. All right. Back to 128, back to 80, back to 0. So these are the values I'm going to use from 0 to 5. So I'm going to graph these. All right. Hopefully you notice that our scale is 10 because 50 is 1, 2, 3, 4, 5 boxes. So if it starts at 80, it goes 50, 60, 70, 80 is right here. All right. Some of these values are going to have to approximate. 128, that's almost 130. So this is 100, 110, 120, 128. It's going to be right below that line. Right below 130. Then at 2, it's 144. So I go to 2 on the x. This is 100, 110, 20, 30, 140. 144 is almost halfway between 145 and 140 and 150. All right, it's too close to tell, so I'm going to put it about half. All right, and at 3, it's 128. So I go to 3, 110, 120, 128. It should match the other point. At 4, it's 80. And at 5, it goes back to 0. All right, this is what it should look like. It should be a curve that should open downward. Then there are bunch of different questions they could ask about this. All right. The first question asks about the domain and range. Remember, the domain is the x values. The range is the y. So the domain, it starts at 0. It hits the ground in 5 seconds. So the domain is 0 to 5. And you could write it just like that. The range goes from 0, right, where it hits the ground, all the way up to the maximum height, up here, which is 144 feet. So your range goes from 0 to 144. All right? And if you're doing this with inequality symbols, it's 0 is less than or equal to x is less than or equal to 5. And for the range, it's 0 is less than or equal to y. is less than or equal to 144. All right? B, we're going to do just by looking at the picture. Determine the time when the ball hits the ground. It hits the ground when it hits the x-axis, so that's 5 seconds. All right? I'll show you how to do that algebraically on another example. All right, C, how many feet does it fall between 2 and 4 seconds? So if you look at 2, it's 144, and at 4, it's 80. So if I write this here, all right, so I'm just going to do 144 minus 80, which is 64 feet. D, what is the maximum height the projectile reaches, and at what time does it reach this height? So the maximum height is 144 feet in 2 seconds. All right, which is also your vertex here. Your vertex is 2, 144. So if they ask you what does the vertex represent, this is when the projectile reaches its maximum height.